This is NASA astronaut Michael Barrett on Earth. And this is Barrett aboard the International Space Station. His face does not look fuller because space food made him gain weight, or because the camera is distorting it. Within minutes of reaching weightlessness, roughly 2 liters of body fluid that gravity normally helps keep lower in the body shift toward the chest and head. The change is visible around the cheeks and eyes. Astronauts call the result, puffy head, bird legs. But the face is only the clue we can see. The same headward fluid shift is a leading suspect in changes at the back of astronauts' eyes. NASA says about 70% of long-duration station crews show at least one finding linked to spaceflight-associated neuro-ocular syndrome, or SANS. So how can removing gravity change a face, thin the legs, and possibly reshape an eye? On Earth, standing creates a pressure gradient through the body. Gravity pulls blood and other fluid toward the legs. Your heart, blood vessels, and muscles continually work against that gradient to keep enough blood reaching the brain. You are so adapted to this arrangement that you normally never notice it. Orbit removes that familiar head-to-foot gradient. The heart still pumps, but fluid no longer pools toward the feet in the same way. More of it occupies the upper body. Astronauts describe a full head, a stuffy nose, and a sensation similar to hanging upside down. At the same time, their calves can look smaller because less fluid remains in the legs. It is not yet the muscle loss that develops during a long mission. This early bird leg look can appear almost immediately. The body reads the extra fluid near the heart as excess volume. It responds by getting rid of water and reducing total blood volume. That helps the facial puffiness ease over the following days and weeks. But it creates a second problem. When the astronaut returns to gravity, there is less circulating volume available, so standing up can cause dizziness or fainting. The visible swelling usually improves. The eye question is more complicated. During long missions, doctors have observed swelling around the optic nerve, folds in the retina, and flattening at the back of the eyeball. That flattening can shift vision toward farsightedness. NASA astronaut physicians Michael Barrett and Bob Thirsk noticed they needed stronger reading glasses in orbit, then began investigating why. The collection of findings is called SANS. Headward fluid shift is a leading hypothesis, but NASA does not claim it is the only cause. Pressure in blood vessels and cerebrospinal fluid, carbon dioxide exposure, inflammation, nutrition, and individual anatomy may all change the outcome. Every astronaut experiences weightlessness, yet the severity varies widely. That uncertainty is what makes the harmless-looking face important. Puffy cheeks fade. Changes at the back of the eye can take months to resolve, and some structural changes may not completely return to their pre-flight state. No astronaut has been reported by NASA to have permanent vision loss from SANS, but a multi-year Mars mission would be longer than any current station stay and too far away for a quick return. To study the problem, astronauts image the retina, measure eye pressure, scan blood vessels with ultrasound, and compare results from before, during, and after flight. NASA also uses head-down bed rest studies on Earth. Volunteers remain tilted with their heads slightly below their feet for weeks, producing a controlled version of the headward shift. One countermeasure looks like the lower half of a vacuum chamber. Lower body negative pressure gently draws fluid toward the legs. Researchers have also tested thigh cuffs and compression garments. Before landing, crews drink extra fluid, and pressure garments help prevent blood from pooling too quickly when gravity returns. None of these is simply a cure for a puffy face. The goal is to control where fluid goes, protect the eyes and brain, and make the transition between gravity levels less dangerous. Look at the comparison again. A rounder face is the first visible sign that the human body is not merely floating in space. It is being replumbed by a new gravity environment. About 2 liters shift upward. The legs temporarily slim. The body reduces blood volume. And in many long-duration crew members, doctors find changes behind the eyes that are still not fully explained. The face is not the danger by itself. It is a warning label for a system we evolved to run under Earth's gravity. If you like decoding the hidden mechanism inside real footage, subscribe. That is what Wyatt Spike does in every video.